Alright, let's get to another case of this function composition. And in this case, I have a f of x and its inverse. And what we're going to do, it's this operation here. We're going to get f inverse of f of x. And let's see what happens. I just want you to notice a couple of things here. F of x, it's x squared minus 4 times x plus 7. It's a function we have already worked with in the past topic of inverse of a function. And actually this inverse here, we got it from the past topic here, doing the past topics examples. And okay, here on the right, I have already plotted the graph of f of x, which is the green one. We just have to add here of course, the restriction, which is x greater or equal than 2 here. And here is the inverse in blue, which is this one, 2 plus x square root of x minus 3. Now, okay, let's get to what we're here for. Just get to business here. I'm going to start working this out in here. Okay, so f inverse of f of x. The first thing we have to do here, I'm going to write it like this. I'm going to write it like this: f inverse of x squared minus 4 times x plus 7, which is, I'm saying I'm going to substitute these three terms in every x of f inverse of x. I'm going to do it in here. 2 plus the square root, I'm going to open here a parenthesis. I'm going to write here x squared plus 4 times x, and I'm sorry, this is a minus 4 times x plus 7. And here we also have this negative 3 inside the root here. I'm going to close the root here. And let's work this through. So this is 2 plus the square root of x squared minus 4 times x. And this positive 7 minus 3 would be a positive 4. This is too, I'm sorry, this is too ugly here. This is positive 4, like this. I'm going to close this root. And look at here something. This x squared minus 4 times x plus 4 is already a perfect square. So it falls into this condition. I'm sorry. 2 times b plus b squared. And every time we have this structure here, we can just convert it into, I'm going to do it like this. Something that is a minus b squared. Now I'm going to apply this statement here on the f inverse of f of x. Continuing here, 2 plus the square root of x minus 2. I have to get the square root of this 4 here, just as I did with the x squared. So I'm going to close it here and get this squared. Now I close the root here. Notice something here. This square here is going to cancel out the square root. So we are going to get here at the end 2 plus x minus 2, which is just like this. So at the end, we can cancel out this 2 and this negative 2, and we get at the end that f inverse of f of x is equal to x. Now, hopefully I think you remember what happened between these two graphs, between the graph of f of x and the graph of f inverse of x. This f inverse is reflected through another function here, another function which is actually the one I'm going to plot here, y equal to x here. y equal to x is the one that separates f of x and its inverse. And it is actually the one we just found here. Because this thing here, I'm sorry, I'm going to this thing here, it's what's represented through this line here, with just the same as saying the y it's equal to x here, which I think is something pretty cool. So let's try to think it through, and I encourage you to do as well, to try on your own the f composed of f inverse, which would be just the same as saying the exact inverse operation of what we just did, f, like this, of f inverse of x, just the inverse operation of what we did. And I think you can infer that you're actually going to get, well, just the same result, y it's equal to x. So anytime you find this, you have this condition where you find a operation such as this one, or even if it's not noticed, for example, if you have, I don't know, f composed of g, and you suddenly get to this result here, y is equal to x, well, the explanation is that it's very likely that the g will be the inverse of f. Okay, so hopefully this was interesting to you. Let's get to something else.